Welcome to this explainer. Let's just jump right in and unpack what is, without a doubt, the single most massive cybersecurity transformation we've seen since cloud computing: protecting autonomous AI workflows. Look, we are rapidly moving away from a world where humans are the main actors on corporate networks. Instead, we're waking up to a reality where non-deterministic machines are literally doing the driving. And defending that completely new enterprise architecture, well, it requires us to fundamentally rethink everything we know about security. To really wrap our heads around the sheer scale of this new threat landscape, you just have to look at this staggering ratio. By early 2026, non-human identities, meaning these autonomous agents and AI copilots, now outnumber human enterprise users by 82 to 1. Think about that for a second. 82 to 1. The vast majority of entities interacting with your data, invoking APIs, and making critical decisions, they aren't human anymore. It's a completely new attack surface, and our legacy security controls just simply weren't built to handle this volume or this kind of machine speed execution. So here is our roadmap for navigating this shift today. We're going to cover the new autonomous threat, anatomy of agent hijacking, architecting the trust layer, just-in-time AI authorization, and finally, governing the agentic future. Let's get to it. All right, starting off with Section 1, the new autonomous threat. Remember the whole vibe coding craze of 2025? Developers were rapidly deploying agentic systems to chase these massive productivity gains. And let's be honest, they kind of left security in the dust. Well, the bill for that enthusiasm has finally come due. We've moved away from those passive, read-only chatbots where attackers just use direct prompt injection, basically trying to jailbreak a chat window. Now, we're dealing with active, autonomous agents. In 2026, these agents have persistent memory, goal execution, and read-write access to high-value databases and even digital wallets. And this introduces a highly dangerous confused deputy problem where attackers trick a really privileged agent into doing their dirty work for them. So how exactly does an attacker pull that off? That brings us to Section 2, anatomy of agent hijacking. How do you hack an AI that's operating deep inside a corporate workflow? The answer is indirect prompt injection. Attackers aren't just typing bad prompts into text boxes anymore. No way. Instead, they are weaponizing incredibly stealthy techniques. We're talking about zero-sizing text, literally setting the font size to 0 pixels, or using CSS suppression to hide malicious commands inside normal web pages, emails, or third-party databases. A human looking at the page won't see a single thing. But when your AI agent scrapes that site or reads that database record, it indirectly ingests the payload. It's like a digital booby trap, and detections of these attacks have just absolutely skyrocketed. And this sets off a devastating chain reaction, something known in the industry as agent hopping, where one hijacked subagent cascades the attack across your entire multi-agent workflow. Picture this. A vendor check agent accidentally ingests some malicious SEO content. It becomes that confused deputy we talked about, and it passes poisoned, yet seemingly verified, data to a downstream procurement agent. The exploit just hops from link to link, completely bypassing your traditional perimeter defenses. The sheer velocity of this blast radius is frankly terrifying. Research from Galileo AI shows that a single compromised agent can poison 87% of downstream decision-making within just 4 hours. 4 hours! Human incident response teams literally cannot keep up with that kind of machine speed propagation. Worse, the orchestration agents sitting right at the center of these workflows often hold the API keys from multiple downstream systems, which basically turns them into giant credential honeypots for attackers. Which means we need a totally new defense model. Section 3. Architecting the trust layer. Traditional identity and access management is basically useless here. An AI agent obviously isn't going to pull out its smartphone to approve a multi-factor authentication push, right? And if an agent uses a static bearer token, well, anyone holding that key is the agent. But incredibly, over 50% of Model Context Protocol servers are still relying on long-lived static secrets. That is a massive blind spot. We have to transition to short-lived, cryptographically signed tokens that map directly to specific agent actions. It's all about bootstrapping trust through identity chaining and ephemeral tokens. But hey, verifying identity is only half the battle. We actually have to verify the AI's logic too. And standard neural verifiers, they fail completely at reliably detecting safety violations, hitting a dismal 13.33% accuracy. Ouch. So we have to rely on frameworks like Agent Verify that use linear temporal logic, essentially formal mathematical proofs to guarantee safety. When you do that, accuracy in detecting when an agent's reasoning has been hijacked jumps to nearly 87%. That is a real game changer. You also absolutely have to contain the blast radius of a rogue agent. Organizations are doing this by strictly isolating agent execution away from the host infrastructure. This means using gvisor for application-level interception or Firecracker micro VMs for really strong hardware isolation, even if it comes with a slight 150 millisecond cold start penalty. For super high-velocity tasks, WebAssembly offers sub-10 millisecond starts with formal memory safety. And to top it all off, we wrap all of this in eBPF kernel sensors to rigorously enforce normal, observed baseline behaviors. All right, moving right along to Section 4, just-in-time AI authorization. Because static defense controls are totally obsolete against machine speed execution. There's a quote here I absolutely love. Standing privileges for non-human identities are a high-risk liability in 2026. And it is so true. The days of persistent, always-on database access are kaput. Today, authorization has to be programmatic. It needs to intercept tool execution calls and issue ephemeral tokens that are valid for literally just seconds. If an agent wants to read a file, the authorization control plane checks the context in real time, grants a token that lives for maybe 30 seconds, and applies real-time data masking so the agent only sees exactly what it strictly needs to see. But what happens if a compromised agent is the one requesting a token? To spot a hijacked agent, AI security investigators use behavioral fingerprinting. They analyze when an agent's intrinsic thinking style suddenly shifts, achieving an 86% detection power. We look at traits like sycophancy, like is the agent suddenly agreeing way too much with malicious user prompts? Are its refusal rates dropping? For instance, GPT-4o typically shows about a 23% variance in its response length. If it suddenly deviates from that baseline, boom, we know its internal logic might be poisoned. Finally, we have to look at the big picture. Section 5, Governing the Agentic Future. Ultimately, we have to translate all of these highly technical architectural concepts into actual boardroom accountability. Enterprises are doing this by utilizing DeFi structures, where blockchain smart contracts permanently record agent actions and enforce really strict spending limits. This perfectly bridges the agent's off-chain brain, which processes the complex reasoning, with its on-chain hand, which actually executes the transactions. By logging every single tool call onto a ledger, we create an auditable, completely untamperable trail, and the smart code itself acts as an emergency pause switch that the agent physically cannot bypass. And let me tell you, you are going to need those audit trails because global standards are arriving fast. Just look at this timeline. By August, executives will face personal liability for rogue AI actions, demanding audit-ready evidence of human oversight. The EU AI Act's high-risk requirements, they are no longer theoretical. The NIST AI Agent Standards Initiative is aggressively pushing for standardized identity protocols. The regulatory wall isn't coming, it's already here. So your immediate action plan has to focus on cleaning up shadow agents, implementing those just-in-time controls, and future-proofing your enterprise. Did you know that right now only 20% of organizations actually have a formal process to decommission AI agents? That creates massive retirement debt where shadow agents just linger in the corporate network with active permissions. You need named approvers, unique identities, and fully documented human-in-the-loop oversight for every single high-risk workflow. I want to leave you with one very provocative question to chew on. As we deploy these agents at scale, ensuring autonomy with absolute control is the defining challenge of our time. So, if an autonomous agent corrupts your production database today, can you point to the exact individual responsible for that cryptographic key? Transitioning to this agentic economy is a massive trust crisis, and we absolutely must build security natively into the infrastructure. Thank you so much for joining me for this explainer, and I hope you leave with a much clearer picture of how to defend your AI enterprise.